Imagine watching a star erupt in high definition, frame by frame, gas jets twisting like cosmic fireworks, or discovering that our galaxy's monstrous black hole isn't the destroyer we feared. Today on Astronomy Daily, we're unpacking Novae caught in the act, stable survivors orbiting Sagittarius A star, and a bold plan to beam sunlight into the night sky. But at what cost to the stars above? I'm Anna, here with my co-host Avery. Let's dive in. Hello, stargazers, and welcome to Astronomy Daily for December 9th, 2025. I'm Anna, your guide through the cosmos from the ground up.
And I'm Avery, orbiting right alongside you. Whether you're sipping coffee under city lights or chasing dark skies in the wild, we've got the latest in space and astronomy to fuel your wonder. Today, we're blending breakthroughs in stellar explosions, galactic survival stories, and even the futuristic twist on illuminating Earth while keeping our telescopes trained on the heavens. Anna, what's got you buzzing today?
Oh, Avery, it's those real-time nova observations. It's like the universe handed us a front row seat to stellar drama. But let's start there and work our way out.
Okay. Kicking things off with the cosmic blockbuster. Astronomers have captured stars exploding in real time, and what they saw has rewritten the script on Novae. Published just yesterday in Nature Astronomy, this study used the Center for High Angular Resolution Astronomy, or Chara array for short, in California, to image two novae as they unfolded, revealing ejections far more complex than a simple blast.
Right, Avery. Novae aren't supernovae. They're thermonuclear runaways on white dwarfs, siphoning material from companion stars. But instead of a straightforward shell of gas, these events showed multi-directional outflows. Take V1674 Herculis, the fastest nova on record. It brightened and faded in mere days, about 6,500 to 29,000 light-years away in our galaxy. Chara's interferometry, basically combining light from multiple telescopes for super high resolution, caught two perpendicular jets of gas timed perfectly with gamma-ray bursts detected by NASA's Fermi Space Telescope.
And don't forget V1405 Cassiopeiae, the slow burner at 5,600 light-years out. It peaked for nearly 200 days, bright enough to spot with the naked eye. The white dwarf held onto its outer layers for over 50 days before a delayed ejection, again sinking with those high-energy gamma-ray rays. It's like the star was staging a multi-act play.
Lead author Elias Adi from Texas Tech calls it a shift from grainy black and white to high-definition video. He told reporters, "These observations allow us to watch a stellar explosion in real time, uncovering the true complexity of how these explosions unfold." Gail Schaefer, Chara's director at Georgia State, emphasized the tech's flexibility. Catching these transient events requires adapting our schedule as targets of opportunity pop up.
Absolutely. As Laura Chomiak from Michigan State puts it, novae are laboratories for extreme physics, linking nuclear reactions on the star's surface to the geometry of ejected material and that zippy gamma-ray radiation. This could reshape how we model binary star evolution and even galactic chemistry.
Thrilling stuff. If you're an amateur imager, keep an eye on the skies. These targets of opportunity remind us the universe doesn't wait.
Shifting from stellar blasts to human ones, the Soyuz MS-27 crew splashed down safely yesterday, wrapping up an 8-month stint on the International Space Station. NASA reports the trio, NASA astronaut Johnny Kim and Roscosmos cosmonaut Sergei Ryzhikov and Alexei Zubrytsky, touched down in Kazakhstan after over 260 days in orbit.
It's a textbook return, Avery. Launched last spring, their mission overlapped with key station upgrades and a packed research calendar. While specifics on astronomical experiments are still filtering in, this crew contributed to ongoing solar observations and microgravity fluid dynamics that indirectly support astrophysics modeling, like simulating plasma flows in stellar atmospheres.
True, and it's a handover moment. The station's now prepped for the next rotation, keeping that continuous human presence humming. No major hitches on descent, per NASA's blog, undocking smooth, deorbit burn on point, and a balmy step landing at dawn local time.
8 months is no small feat. These missions remind us that while we chase exploding stars from afar, boots, or rather spacesuits in orbit, are building the data pipelines for tomorrow's discoveries. Welcome home, crew. Now, for the adrenaline junkies, our weekly launch roundup is stacked. NSFSpaceflight.com's December 8th update highlights a global frenzy. China, Russia, Rocket Lab, ULA, and SpaceX all lighting up the pad this week.
Leading the pack, SpaceX's Starship Flight 6 test from Starbase, Texas, eyeing rapid reusability tweaks after last month's hop. Over in China, a Long March 7A lofted more Tiangong station modules, bolstering their orbital lab. Russia's Soyuz 2.1B from Vostochny sent a classified payload skyward. No spoilers, but whispers of ComSat upgrades.
Rocket Lab's Electron nailed a Dawn launch from New Zealand, deploying smallsats for Earth observation that double as calibration tools for astronomy ground stations. And ULA's Vulcan Centaur roared on its second CERT flight from Cape Canaveral, hauling CERT payloads towards GEO, key for future deep space relays.
No major scrubbers reported, though weather nipped at a few heels. These aren't just fireworks. They're the supply lines for telescopes in space and probes to the stars. If you're tracking live, apps like NSF's are gold.
Agreed. It's a reminder that astronomy thrives on reliable rides to orbit.
Over to exoplanet hunting. The Subaru Telescope in Hawaii has scored its inaugural discoveries, a failed star brown dwarf and an intriguing exoplanet, marking a milestone for its upgraded infrared capabilities.
Subaru's no newbie, but these finds, detailed in a freshspace.com report, showcase its revamped seed survey. The brown dwarf, lurking in a nearby system, clocks in at just 13 to 80 Jupiter masses, too lightweight for hydrogen fusion, hence the failed tag, but it's got a dusty disk hinting at potential planet formation.
And the exoplanet? A gas giant orbiting a young sun-like star about 300 light-years out, with an orbital tilt suggesting a dramatic formation history, maybe a gravitational slingshot from siblings. High-contrast imaging pierced the glare, revealing spectral signatures of methane and water vapor.
Implications? This duo pushes our senses of substellar objects and wide orbit worlds, refining models of how solar systems assemble. Subaru is pointing the way for JWST follow-ups.
A stellar debut, pun intended.
Speaking of galactic neighbors, new research in astronomy and astrophysics reveals our Milky Way's supermassive black hole, Sagittarius A star, isn't the wrecking ball we imagined. Lead author Florian Piesker's team tracked oddballs like G2/DSO, D9, X3, and X7 over 2 decades with the Very Large Telescope's Symphony and NACO instruments, plus fresh 2024 ARIS data.
These objects, in the dense central parsec, where stellar crowds are millions of times our local density, follow stable Keplerian orbits hugging within 0.8 parsecs of Sagittarius A star's 4 million solar mass grip. G2/DSO, not a doomed gas cloud, but a star shrouded in one, resisting tidal spaghettification. D9's a binary pair, cruising steady. X7's elongated bow-shock form is northward bound, untouched. X3, a young stellar unit, accelerates but stays on track.
Piesker notes, the fact that these objects move in such a stable manner so close to a black hole is fascinating. Sagittarius A star is less destructive than was previously thought. Co-author Michael Jacek adds it can stimulate star formation or exotic dusty objects via binary mergers.
This paints the Galactic Center as a stellar nursery lab, not a shredder, challenging destruction models and opening doors to black hole ecology.
Mind-bending. Our black holes got a soft spot.
Okay, wrapping with a provocative proposal. Startup Reflect Orbital wants to launch thousands of mirror-laden satellites by 2030 to beam sunlight Earthward at night, lighting solar farms, aiding rescues. But astronomers are sounding alarms on the fallout.
The plan: low Earth orbit satellites with panels focusing beams of sunlight over 5-kilometer spots, 4 times brighter than a full moon. Proponents tout round-the-clock solar power, but critics crunch the numbers. Samantha Lawler from the University of Regina says it yield mere milliwatts per panel, needing a hordes focused on one spot to matter.
The real thing. For astronomy, it's sky-flooding light pollution on steroids. Robert Massey of the Royal Astronomical Society calls it catastrophic, scrambling observations of faint stars and planets. John Barentine from Silverado Hills Observatory warns of scattered beams disrupting wildlife navigation, birds, insects, migrants via atmospheric glow. Aaron Boley from UBC pushes rooftops over orbits, more efficient and sustainable.
A double-edged sword, innovation versus the dark we need for discovery.
And that's our Cosmic Dispatch for December 9th, 2025. From exploding novae to orbiting survivors, it's a universe full of surprises, gentle and fierce.
Thanks for joining us on Astronomy Daily. Tune in tomorrow for more. Got thoughts on space mirrors? Hit us on social at Astro Daily Pod.
Clear skies, everyone. I'm Avery.
And I'm Anna. Keep looking up.